Hello, I'm Paul Beckwith. I'm with the Laboratory for Paleoclimatology at the University of Ottawa. Earlier this evening, I had an interview with CTV television. They were basically asking me about what's happening in India right now with the heat wave. The temperatures over large parts of the country have hit over 50 degrees, 51 degrees. When there was a heat wave last year in 2015 of lesser intensity, lesser duration, uh, over 2,500 people died from heat stroke, heat exhaustion. You know, many of the ailments that can arise when the temperatures are that hot. So I'm going to go into a bit more detail on what's happening right now and the implications for India. So first thing we'll look at, and you can do this yourself, is Google Climate Reanalyzer. Okay, Climate Reanalyzer, and open up the window, and basically you get a map like this. So in order to look at the temperature anomalies, you can hover the mouse over various menus. So we'll look at the temperature anomaly, and then you can see what's going on here. This is basically real-time data from today. And if you click on this, you can look at different regions of the planet. So you can see where the cold and warm areas are. So here's what's going on in India. You can go here and look at the temperature. We can look at the sea surface temperature here. So it's very, very warm in this region. The scale's here, over 30 degrees Celsius. The anomaly here, it's not much hotter, warmer than normal there, and so on. You can look at all these different parameters. Now, if you look at if you want to, and you can scroll down here and see this other map here of the entire planet for the particular parameter that you're looking for. So the most useful ones that I find on this menu are temperature anomaly and sea surface temperature anomaly. We can also look at what's happening with the jet stream winds. So you can see that the winds are, the jet streams are very wavy, and there's streaks here of higher wind speed. And look at the waviness here in the northern hemisphere. It's an extremely meridional jet stream with very large crests and troughs. So the cold air is coming down here, warm air is coming up here. Let's have a look at what's going on. If I retreat back here, actually what I want to do is just go to the basic website. So let's backspace here. And get to this menu, and let's look at the forecast maps. So we'll look at the Arctic region and the air temperature, for example. And we can play a movie here. And the green is above 0 degrees Celsius. So it's above the freezing point. And what you can see is this cycles through. Every 3 hours, it shows an updated map, and it cycles through the forecast for the next 7 days. And what you can see is these large masses of air above 0 degrees Celsius that are going right up over the sea ice. And of course, the sea ice is dropping much more rapidly this year than any other year on record. In fact, it's about something like 18 days ahead of the melt in the previous record minimum year. So there's not going to be much sea ice left come the end of the melt season around mid-September. In fact, there could be no sea ice left, in which case it would be a blue ocean event. We'll call it a blue ocean event, where there's no ice at all, no ice cap at all over the Arctic Ocean. Basically, the dark ocean is just exposed and absorbs all that extra solar radiation. greatly increasing the heating rate. So this is the air temperature. We can look at the anomaly here, and you can see the temperature scale here. So this area here is very much warmer than normal, and the entire Arctic region is very, very warm. In fact, the temperature anomaly over the entire region is from 3 to 4 degrees. This has been as high as 5 degrees, even 6 degrees I've seen it touch. So the Arctic is extremely warm, and the ice is rapidly going as we transition through our abrupt climate change. If we look at the jet streams, then you can see here, you can see this big dip over North America, a crest here, trough here. You can see the extreme waviness of the jet stream. You can see the extreme streakiness of it here. And look at this dip here. This is a pattern, and these patterns are persistent, and they're directly responsible for the extreme weather events that we see. So let's have a look. Let's look at another site here. If we Google Earth Null School, then this is a great depiction of the globe. And let's have a look at what's going on with the ocean temperatures to start off. The ocean currents and the sea surface temperature. So what you can see, actually let's look at the anomaly. So what you can see is that the very strong El Nino is no longer there. Okay, there's still lots of warm water if you go off the equator, but at the equator or near the equator you have this, the winds have changed direction. Okay, so instead of the winds coming this way or stopping, no longer going from east to west, basically halting, that hot water that sloshed across the Pacific is now being pushed aside by winds coming this way, causing upwelling off of the coast of South America. So that warm water is upwelling, coming to the surface and coming across the Pacific Ocean. If we go over to India and zoom in on it a bit, you can see that the water temperatures here they're a little bit warmer than normal. Normal is very hot for this time of year. If we go to the sea surface temperature here, you can see the temperatures are, in this whole region here, 30 degrees, 29 degrees, and so on. So now let's look at the air temperature over India. So if we go air, surface temperature, and it's also showing the winds, and you can see this sort of thing going on here. So let's expand the view a bit. Bring this up here and expand the view, and let's look at what's going on in more detail. So you can see in this region right now it's about 40 degrees or so. Now let's back off. Let's have a look back in time. So this is 3 hours earlier. I'm going back in time in 3-hour increments. Okay, here we go. We're getting warmer here. Let's keep going back. Okay, so here we are. We're approaching 50 degrees. It's not quite there, but look at the vast region here where this temperature is this sort of order of magnitude, 49 degrees. India has about 1.32 billion people right now. The only country with more, of course, is China at 1.38 billion. But the growth rate is much greater for India. So India will very, very soon be passing China. About a quarter of that population, or over 300 billion people, are severely stressed with not enough water. and also severely stressed because of these very large temperatures. So we can continue back in time, and you can see that there's some cooling on a daily basis. You know, at night, of course, it cools down a bit. Let's go to the maximum for the day, and then let's step back a whole day here. And you can see from day to day, this vast area of extremely warm temperatures in India. So they've had an ongoing heat wave and drought for about, drought for about 3 years or so. So it's basically destroyed the employment of many farmers, so they go into the cities, and many of them end up on the streets in the cities, and these are the people that are most vulnerable to the extremely high temperatures. While we're on Earth Null School, let's go across the world to Canada, and let's have a look. Let's focus in on Alberta and see what's going on there now. So if I can find Fort McMurray here. Fort McMurray is roughly there, I believe. Something like that. So let's have a look at what's happening there. We can go on to the chemistry. And here we go. So this is May 15th. This is CO levels, carbon monoxide levels, very high. CO2 levels, you can see that they're also very high. In fact, and SO2 levels, sulfur dioxide, are also very high. So these are the fires that are burning there right now, and you can also scan through the days and see when the fires are most intense. You can scan through the hours here, like look at 3-hour increments. So what you're seeing is at night, when it cools down a bit, the fires can kind of go a bit dormant, not be as active, and then in the heat of the day, when the wind picks up, then they can spread like wildfires. So you can also go day to day here, and you can look and see what happened. So this fire started about May 1st, and it built up just southwest of Fort McMurray, traveled very quickly, built up very quickly, did cause tremendous damage in the town of Fort McMurray, and it's been spreading ever since. Now, it's kind of dropped off of the news because it's not affecting towns right now, but the fire is, you can scroll through and look at, for example, these gases that come off of the fire, and you can see how it spread over time. So basically, what's happening is we're undergoing rapid changes in our climate. In fact, I've been arguing for many years that we're undergoing abrupt climate change. If you look at the rates of change, the rates of decline of sea ice, of snow cover in the Arctic, the increases of CO2, even though countries are saying, and the International Energy Agency is saying emissions are leveling off, they're actually increasing faster than ever in the atmosphere. I'm talking about CO2. Last year it was over 3 parts per million increase. And this year it looks like we're trending to somewhere between 4 and 5 parts per million increase. So this is extremely worrying. We need to treat what is happening as an emergency. We need governments to declare an emergency, and we need the public to wake up on what is going on and to demand strong action from governments. So I think I'll end things here. I just wanted to, make you realize, if you don't, that places in the world are being disproportionately hit a lot harder than other places. And right now, in this so-called climate casino analogy, it's India's turn this week to be devastated. A few weeks ago, it was Fort McMurray. A few weeks before that, it was Houston floods. We're all in this together, and we're all going to sink or swim together. And right now we're doing